Hi. We're going to go over the practice final here. And so let me just start in. First question. At a high school pep rally, several audience members were asked to come up and compete in a game. The classes of the audience members who came up are shown in the table. What is the mode of the data? Remember that the mode is the class with the largest frequency, and that's clearly this one. And remember that it's the class itself that is the mode, not the frequency. Right? Well, such questions as this will always have the frequency as a wrong answer. Right? You don't want that. You want to choose the actual class. Okay, number 2. The following table describes the responses of a random sample of American fast food customers when they were asked which company's French fries they preferred. Responders were allowed to choose only one restaurant. Well, they're given a bunch of restaurants, how many people preferred them, and so on. Is each pair of categories mutually exclusive? Well, so let's take, Arby's and Hardee's. Are those two categories mutually exclusive? They are, right? Because you cannot choose both of them together. Right? Mutually exclusive means essentially outcomes that can't, or events that can't happen in the same trial of an experiment. So if you ask somebody, in this case, which kind of fries do you prefer? They're only allowed to choose one, so they couldn't choose Arby's and Hardee's, and the same for any other pair. So these guys are going to be mutually exclusive. All right. Let's do number 3 here, see if we can see it. The statistics for a particular data set of insect lengths are listed below. What's the interquartile range for this data? Well, the interquartile range is just Q3 minus Q1. Right? So the IQR is Q3 minus Q1, which is 18.1 minus 13.95. 13.95, I can write that. And what is that number? I don't know, 4.15. Okay. How about number 4? Find the probability that X bar is between 46 and 55 for a random sample of size 36 with a mean of 48 and a standard deviation of 10. This is no problem. The difficulty here is to remember to use the correct standard deviation is all. Right? That probability is going to be normal CDF of, 46 to 55, so 46, 55, and then mean and standard deviation. The mean is 48. The standard deviation is going to be, this is a probability involving X bar. The standard deviation is going to be the standard deviation of the population, which is 10, over the square root of the sample size, so the square root of 36. Okay? And this works out to be, 0.8849 approximately. Okay? So that one. Number 5. Trayvon received the following grades in the fall semester of his freshman year. What is his current GPA? Right, and you're supposed to use the usual point scale. All right, so got 4 classes, various grades, number of credits each class counts. What you need to do first is translate these grades into numerical terms using this point scale. So an A is 4, a B is 3, 3, 4. Right? And then I'm going to add a column here for grade times number of credits. Right? So 4 times 3 is 12, 3 times 3 is 9, and then 12 and 12 again. All right. Now the GPA is going to be the sum of this column, that's 36 and 9 is 45, divided by the sum of this column, which is 9 and 4 is 13. So GPA is going to be 45 over 13, which is about 3.46. That one there. Okay, number 6. A standard 6-sided die is rolled. What's the probability of rolling a number less than 5? Well, the numbers less than 5 are 1, 2, 3, 4, and there are 6 outcomes altogether, so it's just going to be 4 out of 6. Okay. A marketing research company has surveyed a panel of consumers to test a new cereal. The results in the contingency table shown indicate the numbers of consumers by age group who liked and did not like the cereal. Okay, so we got 3 age groups here, 18 to 34, 35 to 50, and over 50. And then they either liked or didn't like that cereal. Okay. What is the probability that a consumer was both between 35 and 50 years old and did not like the cereal? So what's the probability the person satisfied both those criteria? So between 35 and 50 means you're in this row. Did not like the cereal means you're in this column. So there are 207 people in this survey who were both in that age group and did not like the cereal. So it would be the probability, if you just picked a respondent at random, the probability that he would be in both those categories would be 207 over 1200. Right? And that should be somewhere. There you go. Okay. Now let's see. Oh, we can see this. Suppose that cattle in a large herd have a mean weight of 904 pounds and a standard deviation of 64 pounds. If a sample of 37 steers were chosen at random from the herd, what is the probability that the mean weight of the sample steers would be less than 892? So they're talking about a mean here. What's the probability that a mean, x bar, sample mean, would be less than 892? This is just going to be a plain normal CDF problem, but the same difficulty arises, and that is remembering to use the correct standard deviation. So let's see. Left and right endpoints come first. Less than 892 would mean this is minus infinity, and I'll go ahead and use the TI's version of that. And the right endpoint is 892. The mean is 904. And the standard deviation, let's see, the population standard deviation is 64. Then I have to divide by the square root of the sample size. 37 steers were chosen. Right? And that turns out to be, I don't remember. Let's look it up. 0.1270 approximately. Answer A there. Okay, number 9. The following table describes the response. Oh, this is the French fries again. What's the question this time? What is the probability that the next randomly chosen person will prefer Arby's or Burger King fries? Okay, so what we want is, based on this data, compute the probability that a randomly chosen participant in this study here preferred Arby's or Burger King fries to the other kinds. Well, there are 26 people who did prefer Arby's or Burger King fries out of 124 altogether. So the probability that one of these people who was surveyed preferred Arby's or Burger King is 26 over 124. That's our empirical probability. So we say that the next randomly chosen person would have the same probability there of preferring one of those two types of fries. Okay, number 10. Now we're back to the marketing research data. But we have a new question, presumably. The question is, are the events over 50 and liked the cereal independent of one another? Okay, how do you determine whether two events are independent? Suppose your events are E and F. Then you would look at the probability of E and the probability of F. You would get those separately. And then you would also look at the probability of E and F occurring. Right? If those are equal, then E and F are if those two things are equal, E and F are independent. And if they're not equal, then E and F are not independent. So that's the technique here. You compute the probability of E, you compute the probability of F, and you can compute the probability that both occur. And then you compare this, both sides of this little equation here. So let's do this. What's the probability that someone selected is, over 50? Well, let's see, over 50, that's 400 people out of 1,200. What's the probability that they liked the cereal? I'm just going to say liked. Probability they liked the cereal, well, 546 out of 1,200 liked the cereal. 546 out of 1,200. Okay. And what's the probability that they were over 50 and liked the cereal? Well, let's see, over 50 and liked the cereal, that would be that 140 people. So that would be 140 over 1,200. Right? The probability that if you chose someone at random, that person would both be over 50 and like the cereal. Okay, so now the question is, does probability of over 50 times the probability that they liked the cereal equal the probability that they were over 50 and liked the cereal? And if you compute these, you will find no. Right? So these events are not independent. Just compute both sides of this and you'll get two different numbers. These events are not independent. Okay, let's take a look at this one. Number 11. The following scatter plot represents the number of wolf pups that survive winter on the y-axis there, compared to the inbreeding coefficient x. The correlation coefficient is r equal minus 0.83 for this data. Is it appropriate to use the linear model, this line represents the linear model, to make predictions? The answer to that is yes. The sample size is not very large, but it's not very small either. And the correlation is quite strong. 0.83 or negative 0.83 is quite strong. Okay, number 12. The calculator input below represents a simple linear regression of neck circumference, x, and chest girth, y, for a random sample of 19 Appalachian black bears. What is the slope of the line of best fit? Well, the very first line here tells you the equation of the regression line, and its slope is a, right? The coefficient of x is the slope, that's a. And then on the next line, it tells you what a is. So the slope of the regression line is 0.514. Okay. How about this last one on this page, number 13? The frequency distribution below shows times for the 50-yard dash for several high school athletes. What shape would the histogram for this data have? Well, that's pretty easy to tell, right? There's one guy in this low category, then there are a couple of empty categories, and then the numbers in the categories grow pretty quickly. Right? So if you actually made the histogram, let's see, can you see this? Yeah. If you actually made the histogram, it would look like this. There'd be one guy here, nothing for the next two categories, right? And then it would start going up. It would be like this. Drawing this very well, obviously, but it would go up like this. So this is a histogram with very little data on the left. This is skewed left, definitely. And because there are two empty bars here before you get over to this single bar on the left here with only one thing in it, I would say that this has one outlier. So skewed left with one outlier would be the answer to that. Okay, let's see. The following data on the number of televisions per U.S. household are based on survey taken by consumer research firm. In this table, X is the number of televisions in a household and P is the probability of X. What is the probability that a household selected at random does not have exactly 3 televisions? Well, the probability that it does have exactly 3 televisions is clearly 0.39. Right? And so the probability it doesn't have exactly 3 TVs is 1 minus 0.39 or 0.61. Right? And that'll be one of these choices. Okay, the histogram below depicts a sample of 90 values. What type of distribution does this histogram represent? Skewed right. Right? Nothing much to say there. That's a memorized thing. You should just recognize a skewed right distribution. Okay, number 16. When you test the hypotheses, right, null hypothesis mu equals 50 versus alternative hypothesis mu not equal to 50, at the 0.05 level of significance, given that S is 0.4, N is 10, and X bar is 49.5, what's the correct conclusion? So, first question, can I use the CLT? Right? You need either a approximately normal population or at N at least 30. Do we have that here? N is 10, and nothing tells us that the population is approximately normal. So the answer is no, and we choose A. You cannot satisfy normality. That is, you can't use the CLT to assure yourself that the sample means are approximately normally distributed. So you can't do any test. All right. A marketing research company, yeah, this is the serial preference data. Here's the question. What's the probability that a consumer liked the cereal given that he was between 18 and 34 years old? If he was between 18 and 34, there were 400 people who were between 18 and 34. Of those, 213 liked the cereal, so it would be 213 out of 400. Right? Okay, the age in years and the number of hours slept in a day by 6 infants is listed in the table below. Which of the following is the equation of the line of best fit? In other words, the regression line. So we take out our trusty calculator and go to Stat, Edit, and we put ages in X and number of hours slept in Y. And then we hit Stat, go over to Calc, and then down to number 4, lin reg AX plus B. And there it is. Y equal AX plus B with A equal that number, minus 2.29 something, and B equal 15 point something. So we would probably write the equation as y hat is equal to minus 2.29x plus 15.39. And, well, it's not written quite that way here, because very often when equations have a negative coefficient of x, you write them the other way. So it would be 15.39 minus 2.29x. All right, number 19 now. You test the hypotheses. Come on now. You test the hypotheses H naught being mu less than or equal to 1030 versus the alternative mu greater than 1030 at alpha equal 0.05 and find p equal 0.06. What do? Well, to reject H naught, or accept the alternative, we need p less than or equal to alpha. Here we don't have that. 0.06 is not less than or equal to alpha, so we cannot reject the null hypothesis. Okay? That's the only conclusion we can have here. Okay, number 20. The following table French fries again. What's the question? What is the chance that the next randomly chosen person will prefer Wendy's fries? Well, 20 people out of 124 preferred Wendy's fries in the survey, so we'll assume that that's the chance that the next randomly chosen person will do so. Right? 20 out of 124. Let's see. Determine the type of data for the speed of Serena Williams' last tennis serve. Right? That's going to be a continuous random variable, right? Or continuous data, if you like. Right? Think of, no matter how it's measured, let's say it's in miles per hour, it could be any number at all, not just 1 mile an hour, 2 miles an hour, something like that. Number 22. A marketing research company has surveyed a panel. Oh, yes, okay, cereal preferences. What is the probability that a consumer did not like the cereal, given that she was over 50 years old? Okay. How many people were over 50? 400. How many people did not like, out of those 400, how many did not like the cereal? 260. So it would be 260 over 400. You can go ahead and do this with the formula if you like, probability of E and F divided by the probability of F, and you'll get the same number. But if you understand what to do, it's quicker to just go ahead and pull the data right out of the table like that. Okay, let's use this graph to answer the question, how many students are majoring in actuarial science? And let's see, the actuarial science is this bar right here. Seems to be about 12 students or so. It's certainly more than 10 and less than 20, so I'm going to pick 15 students. Okay, number 24. According to a USA Today Gallup poll conducted at the beginning of 2010, after the Haiti earthquake, 63% of Americans favored leaving troops in Haiti until basic services were restored. Results were based on telephone interviews with 1,067 American adults aged 18 or older. What was the sample? The sample was the people they actually collected data from, those 1067 Americans that they phoned. Okay, let X be a normal random variable with a mean of 10 and a standard deviation of 2. Convert the X value 11.2 to a z-score. Well, remember the z-score formula. Z is X minus mu over sigma, using population symbols there. In this case, the X value to convert is 11.2 minus the mean is 10, and the standard deviation is 2. So this is 11.2 minus 10 over 2, which is 1.2 over 2, or 0.6. Number 26. A random variable is normally distributed with mean mu, or mu equal 200, and sigma equal 10. Which of the following is sigma x bar, the standard error of the sample mean for a sample of size n equal 100? So the standard error, the sigma x bar, is just sigma over the square root of n. So here that would be 10 over the square root of 100, which is 10 over 10, or 1. Okay, number 27. The following this is the French fries again. Here's the question. What principle tells us that a larger sample would better represent America's favorite French fries? The answer to that is it's the law of large numbers. Right? Remember, the law of large numbers says that the more times you repeat an experiment, the closer the empirical or measured probabilities come to the theoretical probabilities, right? To the actual real probabilities. Okay, number 28. Determine the type of data for this data set, the Social Security numbers of all Radford faculty. Social Security numbers are qualitative data. Right? They are made up of digits, all right, but they don't come from counting or measuring anything. Okay. Number 29, a marketing research firm, blah, blah, blah. This is the cereal data. What's the question? What is the probability that a consumer liked this cereal? Well, 546 people liked it, and there were 1,200 surveyed altogether, so it's just 546 out of 1,200. A manufacturer guarantees that the mean usage time of its cell phone batteries is at least 12 hours. To test this claim, you randomly select a sample of 83 batteries and find the average usage time to be 11.7 hours with a sample standard deviation of 1.2 hour. If alpha is 0.05, that's the significance level, which of the following shows the correct hypothesis test and conclusion for this situation? So, first, can you use the CLT? You need either n greater than or equal to 30 or an approximately normal population, and here you have a rather large n, it's 83. Right? So I'm just going to note that down, n is 83. Second, which kind of test, Z or T? Well, the answer depends on where the standard deviation comes from. If the standard deviation comes from the population, if you are told the population standard deviation, then you use Z-test. Otherwise, you're going to use a T-test. So reading the problem carefully, you can see that there's the sample standard deviation in here, but there's nothing about a population standard deviation, so you're going to use a T-test here. So far I can rule out the two answers that have Z-test in them. All right? For the rest of this, you have to actually do the test. Right? You have to take out your calculator and do the hypothesis test. And what you will find, I'm just going to tell you this time, what you will find, you'll find that P is about 0.0127. Well, alpha is 0.05, so P is less than or equal to alpha. Right? So that means we can reject the null hypothesis. Right? So we've already ruled out this answer, and we've ruled out this answer. The question is, which of these two do we pick? Well, we pick the one with the correct p-value that says reject H0. And of course, you can reject H0 if there's evidence for the alternative hypothesis, which is what this says right here. So the answer you want is D. All right. Does the following scenario represent a situation that can be modeled by the binomial distribution? A pharmacist with the FDA is currently testing a new drug for abnormalities. There are 2,010 samples from Company 1, 1,280 from Company 2, and 3,120 from Company 3 for a total of 6,410 samples. X is a random variable that represents the number of abnormalities in the total. The probability of abnormality from Company 1 is 0.002, and the probability of abnormality from the other two companies is 0.009. And the question is, of course, is this a binomial experiment or not? Well, you need to know what a binomial experiment is to answer this, and you just go through the list. What do you need? You need a fixed number of independent trials. You need to have on each trial the only possible outcomes being success and failure, and you need the probability of success to be exactly the same on every trial. Okay, so let's go through. Do we have a fixed number of independent trials? Well, yes, we have a fixed number of trials. There are 6,410 of them altogether. Are they independent? Well, there's nothing here that says they aren't, so let's just assume that they are. Are the only outcomes success and failure? Well, it does seem that way. We could call success find an abnormality, and call failure don't find one. Right? So that seems to be the case. And we need the probability of success to be the same on every trial. Now, if we think this is the one that fails, right? If you think of each trial of the experiment as being like examine the results from test 1, examine the results from test 2, and so on, right? There'd be 6,410 of those trials. The probability of finding an abnormality, the probability of success would vary from one trial to another, because some of those would be from Company 1, where this is the probability of finding an abnormality, and the others would be from Companies 2 or 3, which would give you a different probability of finding an abnormality. Right? So this is not a binomial experiment. Right? Just doesn't fit. What value is always, this is number 32, what value is always located at the center of a confidence interval for the population mean mu? Well, those confidence intervals always look like x bar minus e to x bar plus e. Right? On a number line, right, of an axis, they look like this. If this is x bar, then it's x bar minus e to x bar plus e. So the number in the middle is always just x bar. All right. The following table describes the responses. Oh, okay. We're back to the French fries. Here's the question. What is the sample space for this survey? This is an easy question. Right? What are the possible outcomes? Prefer Arby's, prefer Burger King, and so on. And so this is the way we can write these. You want to choose answer A here. You don't want to choose the frequencies. Number 34. Suppose that x is selected from a normal population. This means that x is a random variable, right, that represents sampling from some normal population with a mean of 4.5 and standard deviation of 2. If a single value x is chosen at random, what is the probability that that value x lies between 2.5 and 5? Well, this is just a simple normal CDF problem. Right? It's normal CDF of left endpoint, right endpoint, so 2.5, comma 5, mean 4.5, standard deviation 2. Right? There's no sample size to worry about here. Right? This is not a probability of x bar or anything like that. Or if you like, the sample size is 1, that's fine too. You just use a plain old normal CDF and you'll get something like 0.4401, right, this very first answer. Okay, problem 45, and we got the serial data. That's the question. What's the sample space of this survey? Okay, these sample spaces are really the easiest because this is called a contingency table, remember? And the sample space for contingency tables always is just all the pairs of categories. So 18 to 34 and liked the serial, 35 to 50 and didn't and liked the serial, over 50 and liked, 18 to 34 and didn't like, and so on, right? And so A here is the only thing that could be the sample space. All right, 36. The following represents a binomial experiment, so we don't have to worry about that part. 7 plants are operated by a garment manufacturer in 7 different countries. There is a 10% chance of strike at any time. It is also believed that strikes in one plant do not influence strikes at any other plant. And then there's an explanation which really isn't an explanation anymore. It must be an old question. Right? Everybody in third world countries has cell phones, if nothing else. What is the probability of exactly 2 plants going on strike? And I guess she means, I know who wrote this question, I guess she means exactly 2 plants going on strike at the same time. Right? So what we have here, we have a binomial situation. Right? Our random variable x is number of successes, right? Where we'll define success to mean go on strike. Right? So we want to know what's the probability of getting exactly 2 successes out of these 7 trials where the probability of success on any one trial is 10%. So that is just going to be Binompdf because it's an exact number thing. Right? And the arguments to Binompdf, or Binompcdf for that matter, are npx, the number of trials, which here is 7, the probability, which is 0.1, and then the number of successes we're interested in, which is 2. And if you plug that into your calculator, maybe I ought to just do it to remind you where Binompdf actually is. You go to Math, and then you arrow over to Probability menu, and down to, no, you don't do any such thing. You go to the distributions menu, second vars, and you have to arrow down really far until you get to Binompdf, right? And then you can put in these numbers. There's n, 7, p is 0.1, and then x here is 2. And that turns out to be 0.1240, pretty close. And sure enough, that's one of the choices. Okay. All right, number 37. A certain hypothesis test found a p-value of 0.0579 and did not reject the null hypothesis. Which type of error might have occurred? Well, now, if you did not reject the null hypothesis, that means you accepted the null hypothesis as more likely than the alternative. The only kind of error, well, type 1 and type 2 are the only ones under consideration. There is no type 3 error, so that's just nonsense. Right? The only kind of error in which you accept the null hypothesis is a type 2 error. Right? So it would be a type 2 error in which you accepted the null hypothesis incorrectly. It has to be type 2. Assuming a normal distribution, this is number 38, what z-score is associated with the third quartile? Okay. Well, when we have a mean and standard deviation, we remember the z-score formula, right? It's z is x minus mu over sigma and so on. And that will show up. But for this kind of thing, we need to think about z-score in terms of its definition. Right? Let's suppose that we have this distribution here, right? And we're going to look at whatever it is, I don't know, it's x. We're going to look at its third quartile. Right? That's Q3. Q3 is defined by the fact that 75% of the area under the normal curve is to the left, so the area to the left is 0.75. In other words, this is the same as P75, the 75th percentile. What happens when we transform over to Z? This is really easy once you get it. You transform over to Z, you've got to have 0.75 as the area to the left of the third quartile over here. I'm not going to label that Q3 because it might be confusing. I just want this number D. And all I'm doing is transforming to the x-axis. That's transforming from x over to z. But I can get this point independently of whatever the parameters are for this curve over here. Right? D, can we see this? Yes. D is just going to be inv norm of 0.75 and then 0, 1, but the calculator will assume that. Right? And when you plug that in, it turns out to be, where am I, number 38, I have this here, about 0.67. Well then, that's the z-score of this Q3, 0.67. And that was the question. All right. Our administrative assistant must order, this is number 39, every type of pen the state makes. There are 4 colors of ink, 2 types of ink, and 2 tip widths. How many different pens must she order? Well, there are 4 times 2 times 2 or 16 different types of pen. She has to order them all, so she has to order 16. Now, problem 40. An 8-sided die, which may or may not be a fair die, has 4 colors on it. You have been tossing the die for an hour and have recorded the color rolled for each toss as shown below. From this data, what is the probability that you will roll brown on your next toss of the die? Well, it looks like you rolled brown 18 times. And if it's 18 out of what? Well, let's see, 46, it'd be 64, 99, 145. So 18 times out of 145, it came up brown. That's an empirical probability, right? Probability from repeating an experiment. That's the probability of rolling a brown, as far as we can tell. So the probability you roll a brown the next time, 18 out of 145. Problem 41. Near the holidays, shoppers in a particular store spend an average of $234 with a standard deviation of $94. If this spending is normally distributed, what is the amount of the first quartile? Okay, the first quartile, Q1, is the same as P25, and you can always find percentiles with inv norm. Inv norm of 0.25 in this case, with mean of 234, standard deviation 94. Excuse me. And this turns out to be, hold on, I have it written down here. This turns out to be 170.6, close enough. Right, and it would actually be dollars in this case, of course. Okay, 42. The two box and whisker plots shown below summarize information about the lengths of songs from two different CDs. What is the interquartile range for Alicia Keys' CD? The interquartile range, IQR, is just Q3 minus Q1. Right? In these box and whisker plots, Q3 is the leftmost bar. Q1 is the left bar, and Q3 is the right bar. So this is going to be 220 minus 200, which is 20. Okay, a bag contains 12 different colored marbles. One marble is drawn out. How many different outcomes of this experiment are possible? 12. Right? 12 different outcomes. They're all different. So the answer is 12. I don't know what more to say there. 44. The graph represents the percentage of extinct or endangered species in each animal group. Approximately what percentage of extinct or endangered species are clams? That's this group right here. And that's certainly less than 25%. Right? Otherwise, this would be bigger. And let's see. It's not as small as, just looking at the answers now, it's not as small as 5%, which would be very, so I'd say that's 20%. Just as estimating. Okay. In Virginia's exciting Don't Waste Your Money lottery, a player selects 5 different numbers from the numbers 1, 2, 3 up to 38. Later, 5 numbers are drawn from that same set by a lottery representative, and if these 5 numbers match a player's 5 numbers in any order, then that player wins. What is the total number of 5 number combinations possible? So here we are choosing 5 objects, 5 numbers in this case, from a set of 38. Right? So the number of ways to do that will be the number of combinations of 5 things chosen from among 38. Other ways to write this are 38 choose 5, and also 38 and then a big C and then a 5. On your calculator, remember how to do this. Right? On your calculator, you would use the NCR function, which is in the math menu, I hope. Right? But you have to put the 38 on the screen first, and then go to math, over to probability, and down to NCR, and then you put the 5 on the screen and press enter. 501,942. This one. Okay, number 46. A p-value for a hypothesis test is what? Okay, this is actually pretty hard. Remember where p-values come from. When you do a hypothesis test, you are assuming that the null hypothesis is true, and then you take a sample and find its mean, and then you find the probability of getting a sample mean as extreme as the one you got, that is, as far away from the mu naught given to you as the one you got, or farther. Right, so let's read these and see which one matches up with that. The p-value is, this one says, the probability of selecting a sample at least as extreme as the observed sample, assuming that the null, that's the one, assuming that the null hypothesis is true. If you read through the rest, you would find that they did not match. Number 47. The following scatter plot represents the number of wolf pups that survive winter on the y-axis here, as compared to the inbreeding coefficient x. Assuming that it is correct to do regression on this data, use the linear model of this data, which is given to you here, to predict how many pups will survive winter if the inbreeding coefficient is 0.22. Obviously, you should round to the nearest whole number here. All right, so you regard the linear model, right, y hat equals this, as a formula that lets you predict the y value given an x value. So all you have to do is put in the x value, the 0.22 inbreeding coefficient, and compute y. So y hat here is going to be 6.57 minus 11.45 times 0.22. Right? That turns out to be really close to 4.05, rounding to the nearest whole number, 4. Okay, number 48. The following data is from a sample of beak lengths of white-browed sparrow weavers. Calculate the mean. So you do this the way you do any such thing, right? Go to Stat, Edit, and put the numbers in list L1. You can see I've already put them in there. And then you would go to Stat, over to Calc, and just choose one var stats, once to put it on the screen and once to actually do the computation. And the mean, x bar, is the very top thing here, 10.72 approximately. So we would choose 10.72. All right, 49. Which of the following is not a measure of dispersion in a set of data? So measures of dispersion that we've seen are the range, the variance, the standard deviation, and the IQR. Measures of central tendency are mean, median, and mode. Right? So this is the one that is not a measure of dispersion in a set of data. Okay, number 50. Near the holidays, shoppers in a particular store spend an average of $234 with a standard deviation of 94. If this spending is normally distributed, what is the amount of the third quartile? Well, we've done this for the first quartile, I guess. Remember Q3, this is the same thing as P75. You can get that with inv norm. Inv norm of 0.75, comma, mean, comma, standard deviation. So 234, 94. And if you actually put this in your calculator, you're going to get something like 297.4 or 297.40. Okay, number 51. A survey of 100 adults in the U.S. found that 12% prefer to take their vacations during the winter months. Is that 12% a parameter or a statistic? Well, 100 adults is not anywhere near the number of adults in the U.S., so that number, that 12%, is computed from a sample and is therefore a statistic. Also, of course, we regard any survey or poll results as statistics. Okay, number 52. The sample data in the table below represent running speeds of Tadaran spiders before amputation in centimeters per second. What is the median of this data? Well, you do this in the usual way. Right? You take out your trusty calculator, you go to Stat, Edit, you put the numbers in list L1, and then you go to Stat, Calc, and number 1 there, 1 var stats, and then you have to arrow down, right? And you can see there its median is 3.6. Right? I don't suggest that you do such things by hand. Use the calculator. All right. 53. If all other quantities remain the same, how does increasing the level of confidence from 90% to 99% affect the width of a confidence interval? Okay, two things here. Two ways to look at this. One way is intuitively. Right? If you are 90% confident that the mean is within some number, right? Some margin of error E of the true population mean based on your data, then how could you possibly be 99% confident that the mean was, within that number or less? Right? You would think that the margin of error would have to be wider, would have to be larger, and so the confidence interval would have to be wider to get a higher level of confidence with the same data. And you would be right. It has to get wider. You don't have to have the intuition, though. If you remember what confidence intervals look like, they look like x bar minus e to x bar plus e. Right? And e here is z sub c times sigma over the square root of n. Right? It says all other quantities remain the same except for the level of confidence. And that means sigma doesn't change, n doesn't change. So the only thing that changes is c. C goes from 0.9 to 0.99. Right? And when C increases, Z sub C increases. You've already seen the numbers, but you could easily calculate these two numbers to find out. Right? So if this thing, Z sub C, increases, right, then since this hasn't changed, this whole number E, this product here, will be larger. Right? So the margin of error will increase as you go from 90 to 99% confidence, which will mean the interval will get wider. Okay, 54. When you test the hypotheses, null hypothesis mu equal 200 versus alternative mu not equal to 200 at the 0.1 level of significance, given that S equals 40, N equals 60, and X bar equals 192.5, what's the correct conclusion? So we'll start with the usual questions, which I won't write down this time. Can I use the CLT? Yes, I can, because N is greater than or equal to 30. Second, is this a Z-test or a T-test? Well, that depends on where the standard deviation comes from. If you're given the population standard deviation, you use Z, otherwise T. But if you look through here, you'll see that the only standard deviation you're given is called S. That is a sample standard deviation. Population standard deviation is sigma, sample standard deviation is S. So this is going to be a T-test. Right? And it's going to be a T-test with mu naught equal 200, level of significance, well, that's alpha, we'll use that later, 0.1, S, what your calculator will call S sub x, equal 40, N equals 60, and X bar equal 192.5. If you put that into your calculator's t-test, you'll get a p-value of approximately, and what do you get here? You get a p-value of about 0.1517. Now, since alpha is 0.1, p is not less than or equal to alpha, so we can't reject the null hypothesis. So we should choose this answer right here. P is 0.1517. Do not reject H. 55. The following data represents the number of days a random sample of patients were hospitalized after being diagnosed with a dangerous virus. And there's the data. Assuming that the number of days in the hospital is approximately normally distributed, which of the following is the 98% confidence interval for the population mean based on this sample? Okay, so the usual thing. Start with, can I use the CLT? Here you clearly can use the CLT because you're told that the number of days the population here is approximately normally distributed. Second, will this be a Z-test or a T-test? If you know, or if you're given the population standard deviation, then you use Z, otherwise T. Oh, I don't mean test, I mean Z interval or T interval. Here, we're not given any standard deviation. It'll just be taken from this data, which is sample data, of course. So this will be a T interval. So what do? You take out your trusty calculator, go to Stat, and Edit, and put the data in list L1. Then to actually to find the interval, you hit Stat, go over to Tests, and then all the way down to T interval, number 8 there. Okay. Instead of stats, you're going to be using data. So move over to data and hit enter. And then list L1, frequency, you just leave that at 1. 0.98, yep, that's what we need. And then calculate, it takes a second. And it looks like 18.27 27.73. That's this one right here. 56. The heights in centimeters and the weights in kilograms of 10 people are as follows, and there's a chart given. Determine the simple linear regression equation and use it to predict the estimated weight of an individual who is 172 centimeters tall. Round your answer to the nearest whole number. Okay, so how do you go about this? You're going to find a regression equation. Right? We're going to use it when we're done to predict the weight from the height. So the height will be our x and the weight will be our y. So the height numbers will go in L1 and the weight numbers will go in L2. So if we turn this on and go to stat edit, you can see that I've already put the correct numbers in L1 and L2. After that, all I have to do is go to stat, over to calc, and then choose number 4 there, Lynn Reddick, A plus B. Press enter a couple of times, and there are my coefficients. Right? Y equal ax plus b is the line. A is about 0.49, close enough. B is about 2.12, that's what I'm going to say. A is about 0.49. B is about 2.12, and they're both positive here. Okay. So that's not what the question asks for. The question asks me to predict the weight of an individual is 172 centimeters tall and rounded to the nearest whole number. So what do I need to do? Right? My equation here is ax plus b, which is 0.49, I should say y hat equals 0.49 times x plus 2.12. And so y hat for 172 centimeters, I just plug 172 centimeters into for x, 0.49 times 172 plus 2.12. And that turns out to be, let's see, around 86.4. So rounding that to the nearest whole number, 86. Okay, 57. We are interested in studying whether the true mean age at XYZ Corporation is less than 45 years old. Which of the following are the correct null and alternative hypotheses? For us to figure this out. Well, we don't have any kind of X bar here or any data or anything. All we know is what we, the researchers, are interested in establishing. We want to know whether the true mean age is less than 45. Right? So we're going to take as an alternative hypothesis mu less than 45. And then automatically the null is mu is greater than or equal to 45. Right? So we need to pick whichever pair has that. And it's the first one. Okay. 58. The following represents a binomial experiment. This is the same factory and strike stuff as before, but the question is different. What is the probability of at least 5 factories going on strike? Okay, so the probability that x, that binomial random variable that counts the number of successes, where success here again is going on strike, the probability that this is greater than or equal to 5 is going to be 1 minus the probability that it's less than 5, so less than or equal to 4. That is 1 minus Binompdf of, remember that the arguments are n, p, x in that order. So if the n is 7, there are 7 factories. P is 0.1, the probability of going on strike. And for this, I need to put in 4, right? 1 less than the number that's over here, 4. And this turns out to be, let's see, I have it written down here, approximately 0.0002, a pretty small probability. 59. If 500 confidence intervals, each having a level of confidence 95%, were computed for a population mean mu, approximately how many of the intervals would be expected to contain mu? Well, about 95% of them would be expected to contain mu. That's what it means to be a 95% confidence interval. So it would be about 95% of the 500 intervals, right? 0.95 times 500 is 475. Okay, number 60. Jacinta, wishing to show that the average weight of a freshman girl at her school is more than 115 pounds, weighed 50 such girls, and found x bar equal 118, s equal 8.7. Which of the following correctly describes the test and hypotheses that she should use to test her hypothesis? Okay, so can she use the CLT? Sure. She's got a sample of at least 30. Second, z-test or t-test? Well, again, where is the standard deviation from? If it's from the population, are you tired of hearing this yet? If it's from the population, she should use z, otherwise she should use t. But here, the population is very clearly from the sample. It's given as s, which is the sample standard deviation. So she definitely should use a t-test. Now, what should her hypotheses be? She wants to show that the average weight is more than 115, and she has an x-bar, sample mean, that is more than 115. So she should definitely choose a ha of the form mu is greater than 115. And then automatically the ho is mu is less than or equal to 115, pardon me. Okay, so we just need to choose this t-test with ho less than or equal to, ha greater than. Ho less than or equal to, ha, it's this one right here, B. Okay, 61. What's the probability that z is greater than 2.99? This is just a normal CDF, right? Normal CDF of, let's see, 2.99 to infinity, really, but we'll use this with mean 0 and standard deviation 1, which you don't really have to put in. So you take out your calculator and get normal CDF from 2.99, comma, and then big number. And as I said, you don't really have to put in the 0 and 1. The calculator will assume it, and you get something like 0.00139. Right? So it's going to be 0.0014, as close as this thing can get. Okay, 62. Determine the type of data for the following scenario. The response to the question, are you predominantly left or right-handed? Well, the answer is going to be left or right, and so that is going to be qualitative. It's not even made up of digits, much less actually being quantitative data. All right, which of the following is the 5-number summary for the data below? Well, how do you find that again? You take out your calculator, go to Stat, Edit, and put the numbers in List L1. Then you hit Stat, arrow over to Calc, and go to 1var Stats, and then arrow all the way down. And what you see there, min, Q1, median, Q3, max, that's the 5-number summary. 1400, 25, 28, 47, 52. Looks like B is the correct answer here. 64. Pardon. There is variation in femur length in boys of the same age. Femur lengths of 10-year-old boys are normally distributed with a mean length of 10.2 something and have a standard deviation of 2.2. Which of the following graphs best represents the percentage of such boys whose femur length is over 9.8 inches? Okay, let's draw our own picture here. It's going to be normal, the normal curve, and the mean is going to be 10.2. And the standard deviation is 2.2, and you know that comes right about there, where the inflection point is. So that would make this 8, which would make 9.8, something about right there. And we're looking for a graph that represents the area over the probability that the femur length is over 9.8 inches. area to the right of 9.8, and so it pretty much has to be this one right here, A. Okay, 65. The following are the times in seconds it took for a sample of 9 sports cars to go from 0 to 60 miles an hour. What is the standard deviation of this data rounded to 2 decimal places? Well, you know how to get the standard deviation. I won't even do it. You put the data in list L1, and you go to stat, calc, 1var stats, and you see the standard deviation. The problem is you see 2 standard deviations. You see the sample standard deviation and the population standard deviation. And the problem here is to figure out which one you should use. Now in this case, it's pretty easy since it actually says a sample of 9 sports cars. You know it's going to be the sample standard deviation that your calculator abbreviates S sub x. It's about 1.37. In general, it might not actually say it's a sample, and you'd have to infer it from what was said. Okay, 66. The age in years and the number of hours slept in a day by 6 infant is listed in the table below. What is the correlation coefficient? So how do you do this? You get your calculator out, and you go to stat, edit, and you put the X data in list L1 and the Y data in list L2. And then you go to stat, calc, and down to linreg, AX plus B. There you go. Hit it again, and you can see, I hope you can see, right, R and R squared. And here we're after the correlation coefficient, so it's like minus 0.788 about. And so the correct answer is minus 0.79. 67. What value of probability of the x equals 5 makes the following into a PDF, the probability distribution function? Well, what do you need? You need all these values to be between 0 and 1 inclusive, and you need all of them to add up to 1. So the probability x equals 5 has to be whatever would make all these guys add up to 1. Let's see here, 0.25, 0.3, 0.4, 0.45. So all these guys add up to 0.45, so we need 0.55 there for the probability x equals 5. 68. If the sample variance for a set of data is 144, then what is the standard deviation for this data set? Remember the standard deviation, let's say sample, so the sample standard deviation is the square root of the sample variance. In this case, the variance is 144, so this would be the square root of 144, which is 12. If I were given the standard deviation and asked for the variance, I'd square the standard deviation to get the variance. Same kind of thing. 69. A soft drink maker claims that the mean calorie content of its beverages is 26 calories per serving. If a hypothesis test is done and the decision to reject the null hypothesis is made, how should the conclusion be written? Okay. If a hypothesis test is done, the null hypothesis is going to be mu equals 26, right? That's H naught. And so the alternative would be mu not equal to 26. We would only reject the null hypothesis if the sample mean were far enough away from 26 to provide strong evidence that the null hypothesis was wrong. That's the way hypothesis tests work. Hypothesis tests work. Right? So we have evidence to suggest that the mean is not equal to 26. Okay, 70. Which of the following statements about the central limit theorem is not true? Okay, we'll just go through them. The mean of the sampling distribution is equal to the mean of the population, right? That's mu sub x bar equals mu, which is true. The distribution of the sample standard deviation, well, it doesn't matter what it is because the central limit theorem doesn't say anything about that. It has to be this. Let's look at the other possibilities anyhow. The standard error is sigma over the square root of n, and that's correct. The standard error is sigma x bar, which is, sigma over the square root of n. This one says when n is sufficiently large, the distribution of the sample mean is approximately normal, and that's also part of the central limit there. Okay, 71. Janet tested the hypotheses mu less than or equal to 50 versus mu greater than 50 at the 0.05 level of significance by taking a sample of size 19. If she found a sample mean of 53.7 with sample standard deviation 5.1, which of the following should she report? Okay, so always the same questions. Can she use the central limit theorem? Here the answer is she cannot. There is nothing that says the population is approximately normally distributed, and her sample size is too small to use the central limit theorem to guarantee the normality of the distribution of sample means. And so what she should report is, you didn't give me enough information, I can't do this test. 72. What value for the probability x equal 5 makes this into a probability distribution? And you do it exactly the same way as the last one. What do you get here? 45, 55, 60, 0.4. 73. The following is a binomial experiment. If we roll a 6-sided fair die 10 times, which of the following is the probability that all of the rolls will be a 1, 2, 3, or 4? Okay. So we're going to roll this die, and we're going to say that success is get a 1, 2, 3, or 4. And then that says the probability of success is 4 out of 6. 6-sided, it's fair. It's just 4 out of 6. Okay, and what we need then, we need the probability that x, remember that's the binomial, that's the random variable in a binomial experiment that counts the number of successes, is equal to 10. So this is going to be Binompdf, which you use when you need the exact probability that x will be exactly something. And remember the arguments are npx, the number of trials, which is 10, the probability of success on any one trial, which is 4/6, and then the number of successes we're interested in, which is 10. And you just take out your calculator. Binompdf is on the math probability menu, and that turns out to be, let's see, I have it over here somewhere, 0.0173. That one. 74. It is known that the number of points scored by the winning team in all NCAA games is normally distributed with sigma equal 10.9. A fan randomly selects 100 games for which she finds x bar equals 75.8. Which of the following is a 92% confidence interval for the population mean? Okay, so can she use the CLT? Yes, she's got an n that's plenty large, n is 100 here. Let's see, what else? Is this going to be a z interval or a t interval? Well, it's going to be a z interval if we know the population standard deviation sigma, and here we do. Okay, so now we can actually do this. We take the calculator out, and let's see. We want to go to stat, tests, and this is going to be a z interval, so number 7 down there. It's with stats, so put the highlighting on that and press enter, and start entering stuff. Sigma is 10.9, population standard deviation. X bar is 75.8 for her sample. N was 100. Her confidence level she wants is 0.92. And then we just calculate 73.892, 77.708, 73.89, 77.71. It's A. Okay, 75. Determine whether the following is a binomial experiment. The FBI reports that 34% of burglars enter a residence through the front door. a random sample of 36 burglaries is taken, and the number of entries through the front door is noted. So what do we need? We need a fixed number of independent trials. We need the only outcomes on a trial to be success or failure, and we need the probability of success to be the same on every trial. Do we have all of that? Is there a fixed number of trials? There is. A trial here should be thought of as examining the records for one burglary and determining whether or not the burglar came in through the front door. So yes, we have 36 trials because we're going to look at the records for 36 burglaries. Are they independent? Well, we have every reason to think they are, since the sample was chosen randomly. Is the probability of success, are the only outcomes success and failure? Yes. A burglar either came through the front door or he didn't. And finally, is the probability of success the same on each trial? And the answer to that is yes here also. Since the probability has been determined to be 34% for all burglaries, we can assume that it's 34% for any one burglary. So this is a binomial experiment. Okay, 76. A population is bimodal. A sample of size 39 is taken from this population. The distribution of sample means is approximately normal. Which of the following tells us this? Well, that's a big part of the central limit theorem. Right? Under the right conditions, n greater than or equal to 30, or the population approximately normally distributed, the sample means are approximately normally distributed. All right. 77. Finals are set for the 6 sprinters running the 50-yard dash in the state championship. In how many different ways could these runners place first, second, and third? Well, there are a couple of ways to do this. Certainly the simplest way is simply to think this way. Well, let's see, we have 6 runners, so when we go to choose a first place winner, there are 6 possible choices. The same person can't come in both first and second, so we only have 5 choices for the second place, and then 4 for the third, and that is 120. You could also think, well, I'm choosing 3 sprinters out of 6 where order matters. So that would be P of 6, 3, also written 6P3, and you could use that NPR function in the math probability menu, right? And you would get the same answer, 120. 78. The calculator output below represents a simple linear regression of neck circumference, x, and chest girth, y, for a random sample of 19 Appalachian black bears. And it's the usual output. There's the form of the regression line. There are the coefficients a and b, slope and intercept, and r and r squared. What's the value of the correlation coefficient? Well, the correlation coefficient is r, so it's 0.887. What's the probability that z is between negative 1.02 and 1.02? Well, you just take out your calculator. That is nothing but a normal CDF problem, right? And the normal CDF of minus 1.02 rats to 1.02, and that turns out to be about 0.6923. 80. When the hypotheses mu less than or equal to 34 and mu greater than 34 are tested with alpha equal 0.05, given that sigma is 1.2 and a sample size of 14 taken from a normal distribution produced x bar equal 35.1, which of the following is the correct conclusion? So, can we use the CLT? We got a pretty small sample size, but we're told that the population is normally distributed. So yes, we can use the CLT. Next, is this a Z or a T test? Sorry. It's a Z test if we know the population standard deviation sigma, and we do. So this is going to be a Z test. So we just take out our calculator and start plugging numbers into Z test. Let me move this so I can do that. Okay. So stat tests, the very first one is z-test. We're going to be using stats. What do we have here? Mu naught is 34, right? The number involved in the claim about the population mean. Sigma is 1.2. X bar is 35.1. N is 14. And here we put in the alternative hypothesis, greater than mu naught, and go to calculate. Looks like P is 3.02 times 10 to the minus fourth. P is about 3.02 times 10 to the minus fourth. So that would mean move the decimal point back 4 places. That would be 0.0003. That's close enough. Now that number, 0.0003, is a lot less than 0.05. Right? So we will, right? So P is less than or equal to alpha, so we reject H naught. When P is low, reject the hoe. So what do we have? P is about 0.0003, reject H naught, this one. Okay, 81. In 2010, the average math SAT score for students at a particular school was 495. 5 years later, after implementing an after-school prep class, the school conducted a test to determine whether the average score had increased. If a type 2 error occurred, which of the following happened? Okay. A type 2 error means that you accept your null hypothesis as more likely than the alternative, even though the null hypothesis is false. Okay. What is the null hypothesis here? Well, their null hypothesis would have to be mu less than or equal to 495, right? Because that was the standing situation until they made the change. And so now they're trying to see whether it has increased. So that increase would be that it's greater than. This would be their ho, and their ha would be mu is greater than 495. If a type 2 error occurred then, they accepted the null hypothesis, even though it's false. They accepted the scores were still less than or equal to 495, even though in fact they had increased. Let's see. They concluded that the mean score is not now greater than 495, when in fact it is. Okay, that's the one. Okay. All right. '82. A basketball fan is interested in estimating the true average number of points scored in men's NCAA basketball games. She has randomly sampled 150 games and has determined that the sample mean is 118 and the sample standard deviation is 29. What interval did she get when calculating the 92% confidence interval for the true mean? Okay, same stuff as usual. Can she use the CLT? She can. She's got n equal 150. Right? That's plenty big enough. Second, is this a z-test or z interval or t interval? It's a z interval if she has the population standard deviation, but she doesn't. She has the sample standard deviation. Right? So this is going to be a t interval. Okay, and then you just need to take out the calculator and put in the numbers. So let's do that. Trying to get some of the glare off of it. All right. So stat tests go down to t interval. Number 8 there. Okay, this is going to be with stats. And we'll start putting them in. X bar, right, she got 118. Sample standard deviation was 29. 150, that's our sample size. She needs a 92% confidence interval, and then we hit calculate. And there's the confidence interval, 113.83, 122.17. that one. 83. Near the holidays, the amount spent by shoppers in a particular store is normally distributed with standard deviation $94. What is the minimum sample size that will ensure a 95% confidence interval if we want to estimate the mean amount spent to within $10? Okay. Remember that the difficulty here is always in reading. You have to remember you're being asked for a minimum sample size, so you cannot compute the margin of error. It has to be in the problem. Right? Remember how this minimum sample size thing is done. First thing you do is compute this number, we'll call it n, and that is it's going to be z sub c times sigma over e, the margin of error, squared. And there's no way to calculate e, it has to be given to you. Okay, so here c is 0.95, so that says z sub c is inv norm of 1 plus 0.95 over 2. Remember to add these together and then divide by 2. So here we go. When I add them together, I do it in my head, so I'll do this. Inv norm of 1.95 over 2. 1.96. It gets rounded to. So we'll call that 1.96. All right. Sigma is 94. E is how close we have to get to the population mean. And so E is going to be 10. So this number here is going to be 1.96 times 94 over 10. And then when I get done, I'm going to square that. So 1.96 times 94 divided by 10 is 18.424. Then I'm just going to hit my x squared button, and it'll give me 339.44 approximately. And when you do minimum sample size, you have to round up. Even if it's 339.0001, you have to round it up to 340. So 340 is the minimum sample size here. Okay, number 84. Suppose that the serum cholesterol level of a population of adult males is normally distributed with mean mu equal 100 and standard deviation sigma equal 20. Approximately what percentage of males have cholesterol level above 140? Okay. Let's make a picture. It's normally distributed, and the mean is 100, so it's right in the middle there. And that means 140 is over here somewhere. We're asked for the percentage of males who have cholesterol level above 140, and that's going to correspond to the probability that a randomly chosen male, adult male here, has cholesterol level above 140, right? Because if you have, say, 100,000 males, right, and 7% of them have cholesterol levels above 140, then the probability that if you picked one of those people at random, he would have a cholesterol level above 140 would be 7%, right? It would be this area right here, whatever the probability is, whatever the area greater than 140 is. So all you need to do here is find that area and then interpret it as a percentage. So this is going to be normal CDF of 140 to infinity with mean 100 and standard deviation 20. And I trust you can put that in the calculator. Oops, can't see this though. So this is going to be about 0.02275. So that's about 2.275%. So I would choose the answer 2.3%. Okay, that's it.